everyone. Today we're going to start chapter 3, which is matter and energy. This is going to be about classifying matter. So just some things you need to remember. Everything that you can see is made up of matter. There's lots of different kinds of matter, but it's still matter. Okay? And matter is defined as anything that occupies space and has mass, or takes up space and has mass. So even things you cannot see, like dust or just really small, let's say like dust mites even, or even molecules, those are still matter. Just because you cannot see them without magnification doesn't mean they're not matter. So matter is composed of atoms, which we're going to start talking about this chapter. We're also going to encounter some molecules this chapter. So as far as atoms and molecules go, all matter is composed up of atoms. And here in this example, we've got particles. They're aluminum atoms in this aluminum can. Okay. It can also be composed of compounds or molecules, which we'll talk about in a little bit. But here we've got isopropyl alcohol. So this is one molecule of that rubbing alcohol. Keep going. All right, so matter can be classified into its three states of matter: solid, liquid, and gas. Okay, and water can exist in all three of those, as can any matter can exist in all of those. So I do want you to think about that, because lots of students think, oh, this book can only be a solid. Well, if I heat that book up enough, it can be a liquid. Okay, it's just a matter of how we make that happen. So, in ice, which is a solid, the molecules are closely spaced and they vibrate around a fixed point. In liquids, they're free to move around. They're still closely spaced, but there's more space to move around, so they can flow past one another. And then in water, as steam, so a gas, there's large distances between them, and they don't interact with one another. The particles don't. So here are images of that. Remember, here, these ones vibrate just around their fixed points. These are free to move, but still very close. And these ones, lots of space. Lots and lots of space between them. And they don't interact with each other. So, specifically about solids. Atoms or molecules are packed close to each other in their fixed locations. Also, we talked about this, they vibrate. They don't move around each other, they just kind of vibrate in place. And one of the most important things, solids have fixed volume, which means they keep their volume, and a rigid shape, which means they also keep their shape. So we're talking, if I put a pen into a cup, it still has the volume of the pen, and it still has the shape of the pen. There are different types of solids, which we'll talk about much later in the year in the second semester, but there are crystalline solids and amorphous solids. So those crystalline ones are what we normally think of solids. They have a geometric pattern. Again, this will be discussed later on in the year. I'm not going to test this now. Okay. Amorphous solids don't have a long-range order, so this is more like rubber and plastic, things that are easily changed into other shapes. So here's our well-ordered structure of our crystalline solid versus the amorphous, not very planned out structure. Okay, most solids we encounter are these crystalline solids, especially in chemistry. So most of our solids will look like this image here. Liquids. Those are atoms or molecules that are close to each other, but they're free to move around. Remember, that's why they flow, because they're free to move around. Okay, liquids do have a fixed volume, but They assume the shape of their container. So if I pour a water bottle into my cup that has ice in it, it is still the same volume, but now it took the shape of the cup instead of the shape of the water bottle. Gases. Gases are atoms or molecules that are separated by large distances, and they're completely free to move around. And they do not interact with each other, but they are compressible. That word means able to be squeezed down or squished. Okay, and then gases will assume the shape and the volume of their container. So a gas will take the entire container and it'll just fill it up. So gases are compressible. Here's an image of a piston. Notice the bottom one has that gas and it's got a lot of space to squish it down. But that solid at the top, there's not a whole lot of space, so you cannot compress that. This is just a table showing you everything. So if you need something to make sure you have printed, this is what I'd look at. As far as classifying matter goes, we're going to classify them into two major categories, and then we'll break down those categories more. So a pure substance is the first category. That's composed of only one type of atom or molecule. And then a mixture is composed of two or more different types of atoms, but they're combined in these variable proportions, which we'll talk about what that means. But variable means they're not the same. Like the proportions aren't fixed. So the first part of a pure substance is elements. The thing you need to know about elements is that they cannot be broken down at all. If we try to break an element down, all it is protons, neutrons, and electrons, which is no longer a pure substance. Okay, all the elements are found on the periodic table. Okay, there is a periodic table on mastering that you can just click and it'll pop up. So helium is a pure substance. It is only helium, so that is an element. Compounds, on the other hand, are pure substances, but they're composed of two or more elements in fixed proportions. Okay, what this means is the proportions of the elements that make up the compound are always the same for that compound. So like water is always 2 hydrogens to 1 oxygen. If I change that, it becomes something else. And table salt is 1 sodium and 1 chlorine. If I change that ratio, it's no longer table salt. The next thing, compounds can be decomposed, and this is by a chemical reaction. Okay, a chemical reaction can break those apart. So elements cannot be broken at all, but a compound can be with a chemical reaction. So here we've got water. It's a compound. It's got that fixed ratio of 1 oxygen to every 2 hydrogens. Okay, so remember the compound has the fixed definite proportion. A mixture is a variable proportion. Okay, so here's some examples of mixtures. We've got salt water, which is a mixture, and we've got air, which is a mixture. Both of these are mixtures because there's different types of atoms, so that's what makes it a mixture, and they're not in a fixed proportion. It doesn't matter what the proportion is. Okay, so a pure substance can either be an element or a compound, and a mixture can either be homogeneous or heterogeneous. Here is a concept map or like a flow chart of what matter can be broken down into. Remember elements, so this cannot be broken. And that's just one thing from the periodic table. A compound is a definite proportion. And it's chemically broken. Okay, then we're going to talk about mixtures. Remember, these are variable proportions. Okay, so right now, well, hang on. Oh, I didn't talk about homogeneous and heterogeneous. Sorry, y'all. So homogeneous means the same throughout. So this is like, can you pick out the pieces? If you can, it's a heterogeneous. Like, you can physically pick out the pieces. If it is not that, it's homogeneous. So you can still separate it, but you cannot physically pick out the pieces. And then these are separated physically. So like here in this tea, you can maybe filter that tea that's the homogeneous mixture. But the heterogeneous mixture of oil and water, you could just pour off that top layer of oil. So the difference between the hetero and the homo, you can physically just pour off the top. For homogeneous, you're using a filter to help you. So you're not physically doing it. Okay, so looking at these, we've got, first, you're going to need a periodic table to look at. Okay, a lead weight. So lead is Pb, which is an element. So I'm going to write A, pure substance, and I'm going to write element. B, seawater. You should know that seawater is a mixture. There's a lot of stuff in seawater. The question is it homogeneous or heterogeneous? So just in the water, if you were to pull a cup of water out of the seawater or out of the sea, could you physically separate that? Like the salt from the water, things like that. I would say no. So I would say this is homogeneous. If you wanted the salt out of it, you could evaporate the water or you could filter it. C, distilled water. That is a pure substance. When things are distilled, that normally means you took out all the impurities. So like the things that are in the water, like tap water, and we just now have the compound. And then D, Italian salad dressing is a mixture. And if any of y'all's parents have ever bought that kind of dressing, or maybe you like that dressing, it likes to separate, which makes it heterogeneous. Because if you don't shake it up first, you could pour off some of the layers. Okay, let's try some more. Mercury. Mercury is Hg, which is a pure substance, and that's an element. B, exhaled air. That is a mixture. And it's homogeneous. Chicken noodle soup is also a mixture, but it's heterogeneous. So I specifically don't like celery, or at least the really big pieces of celery in chicken noodle soup, and I will pick them out if they're in there. Then sugar, you should have learned about sugars last year in biology, but those are pure substances because they're compounds. Most sugar y'all think of is glucose, C6H12O6. So that's a compound. It's always in that ratio if it's glucose. All right, so summarizing. So matter can either be pure or a mixture. Pure substances are either elements or compounds. A mixture is either homogeneous or heterogeneous. Remember, mixtures are composed of 2 or more elements, 2 or more compounds, or combo of both. All right, that's it for today. Y'all have a great day.